Hi friends, this is Praharsha from ECE section B. Today I want to discuss about the topic differentiators. This is the important topic in operation amplifiers. So let us discuss the basics of the differentiator. Differentiation. Differentiator is the differentiating the input signal with respect to time. If you take Pin is the input, the output is the The output is the differentiation of input with respect to time. Differentiator is used to identify the high frequency components from the input signal. See, it is the input signal. If you see these region, they have constant input. This means they have low frequency, but these lines are varying. This means these have high frequency. So if you see the output, the the downlines having down spikes and uplines having upper spikes. Differentiator is essentially a high pass filter, means it allows only high frequency signals, means the output signals should have only high frequency signals, and it does not allow the low frequency signals through it. Let us discuss about the topic of operation amplifiers as a differentiator. Let us observe this operation amplifier. It is in the negative feedback. It means in negative feedback, the positive and negative terminal should have the same voltage. Here you can see the positive voltage is grounded, means the the voltage across the negative voltage also should be 0 volts. So here I am writing 0 volts. And as you know, operation amplifiers has infinite input impedance, means let us take that IB is the current flows through operation amplifiers. It is almost is equal to 0, and we have input voltage VIN. Due to this input voltage, some current IC flows through the capacitors. This goes through this capacitor, and here the current IC is bisected into current IB and IR. This current IR flows through the resistor, and we have to take this node, and we should apply the KCL across this voltage. As we know, by applying KCL, current IC is equal to IR plus IB. As we know, the current IB is approximately is equal to 0. We can write current IC is equal to current IR. Current IC is the current flows through capacitor. This one we can write current IC is equal to capacitance of the capacitance C into change in input voltage with respect to time, and the current across the voltage we can write it as change in voltage by resistance of the capacitor. Here the voltage is 0, and here the voltage is V output voltage. So we can write 0 minus V out by resistance R, and we can simplify it. V out is equal to minus CR by dV by dt. By this we can say the output voltage of the amplifier is directly proportional to change in voltage of the input. This is the principle involved in it. Let us discuss input and output waveforms of differentiator. If you observe here, the input wave is a triangular wave. Here the line is with positive slope. If you differentiate this one with respect to time, we will get a positive constant. And here the line is a negative slope. If you differentiate it with respect to time, we will get a negative constant. This triangular wave, by By using differentiator, we can convert it into a square wave. And let us observe this graph. Here the input voltage is constant. If you differentiate constant with respect to time, we will get the output voltage is 0. So the output voltage with respect to time is 0. And let us observe this this input wave. It is in form sine wave. We can write Vin is equal to Vm into sine omega t. If you differentiate with respect to time, you will get Vm omega cos omega t. The output wave form is in cos wave form.